Welcome to this explainer. Today, we're diving into a massive, mind-bending thought experiment. We're going to scale all the way from how our human brains literally process the very concept of time, right up to the heavy physics of actually traveling through it. So, if you've ever wondered how the everyday words coming out of your mouth connect to the possibility of zipping through a wormhole, well, you're exactly in the right place. Let's just run through a quick roadmap for today. 1. The language of time. 2. Traveling to the future. 3. The infamous grandfather paradox. 4. Causal loops and jinn. And 5. The universe's safety net.
All right, Section 1, the language of time, how the mind encodes temporality.
We're actually starting on the micro level here. Before we even touch physics, we have to look at how humanity first tries to manipulate time internally, through the cognitive frameworks of language. It turns out, research out of the National University of Uzbekistan makes a fascinating point. Time isn't just a ticking clock on your wall. It's a massive foundational dimension of human language itself. It completely saturates our syntax, our semantics, our whole worldview. We literally can't speak or even formulate a thought without placing ourselves somewhere on a timeline.
So, before we can even dream of building a real-deal time machine, our brains use these built-in linguistic tools, things like temporal deixis and aspect, along with tense and mood, to effectively construct our subjective, everyday experience of time. We're constantly encoding whether an event is in the past, present, or future, and whether it's ongoing or completely finished. Basically, our language dictates our cognitive reality of time passing.
Okay, moving on to Section 2, traveling to the future, the hardware of time travel.
Let's shift gears from how we talk about time to the actual hard science, the highly probable technologies that could physically push us into the far future. Experts actually argue that future-directed time travel is practically overdetermined, which really just means we have at least two distinct, highly viable paths to get there. On one hand, we've got suspended animation, or biostasis, basically preserving a biological body to wake up centuries later. On the other hand, there's super-fast rocketry. This relies on Einstein's relativity, where cruising near the speed of light slows down your aging relative to everyone back on Earth. Both of these rely heavily on what scholar Charles Tandy calls embedded subjective time, to basically outwit our own biological clocks.
Taking a step back, Charles Tandy outlines 8 theoretical types of time machines. It's like a bird's-eye view of humanity's roadmap. Notice how the first 4 are all future-directed, things like advanced biostasis and near-light-speed rocketry. Scientists are actually pretty much in agreement that these are highly likely to happen. But look at numbers 5 through 8. That's where we cross the line into past-directed time travel, whether it's just viewing the past or actually interacting with it in a branching multiverse. And man, this is exactly where the physics get incredibly tricky.
Which leads us right to Section 3, the grandfather paradox, breaking the past. Because the second we shift from moving forward to moving backward, things get extremely messy. We are immediately forced to confront the terrifying logic of the consistency paradox. You probably know this as the classic grandfather paradox. Modal logic tells us that if it's necessarily true that the past happened a certain way, then changing it is flat out impossible. If you travel back and prevent your ancestors from meeting, you could never be born to build the time machine in the first place. It's a total impossible logical contradiction. It is the ultimate roadblock to traveling backward.
All right, Section 4, causal loops and jinn, objects from nowhere. Now, there's another kind of paradox that doesn't actually erase your existence, but it definitely begs the question of where existence even begins. This is the causal loop, or the bootstrap paradox. In a causal loop, an object's timeline loops back on itself perfectly. Think about this scenario. A playwright gets a watch from an old woman. Years later, he travels back in time, meets the woman when she's young, and gives her that exact same watch. So, where did the watch actually come from originally? The answer is nowhere. It just exists in the loop. This kind of thinking leads to some wildly absurd sci-fi scenarios, like Robert Heinlein's famous character who literally becomes both their own mother and father. Mind-bending, right?
Back in a 1992 paper, physicists Andrei Lasev and Igor Novikov actually labeled these originless items as jinn. They named them after the mythological beings from the Quran that leave absolutely no trace when they vanish. It's a pretty great detail, honestly, proving that even rigorous academic physicists can have a tasteful sense of humor when reality starts breaking down. These jinn basically exist perfectly and self-sufficiently within the laws of physics, even though they have absolutely no clear beginning.
To really test the absolute limits of these loops, physicist Joseph Polchinski came up with a famous thought experiment.
Imagine firing a billiard ball into a wormhole at the exact perfect angle so that it pops out in the past, rolls across the table, and smacks into its younger self, knocking it completely away from the wormhole. He designed this to force the universe into a paradox without relying on messy human free will or grandfathers. It's just straight up simple physics. So what happens? Does the ball go in or not?
Let's find out in Section 5, the universe's safety net, resolving the paradox.
How exactly does the cosmos protect itself from Polachinsky's rogue billiard ball and reckless human time travelers? Well, let's look at the universe's ultimate safety net, the Novikov self-consistency principle, developed by Igor Novikov in the 1980s. Novikov proposed that local physics just simply will not permit causality violations. If you try to change the past, the probability of you succeeding is exactly zero. History is already a fixed, self-adjusting, completely consistent cycle. The universe will literally censor any attempt to break it.
So here is the absolutely crucial point about how this solves the billiard ball problem. Two students at Caltech, Echeverria and Klinkhammer, proved mathematically that the billiard ball does not break the universe. Instead of knocking itself away, it emerges at a slightly different angle, delivering a glancing blow. And that blow alters the younger ball's trajectory just enough so that it enters the wormhole and travels back in time to deliver that exact glancing blow. The universe just naturally self-corrects to maintain the loop.
And this brings us to a really staggering realization, brilliantly captured by physicist J. Craig Wheeler. He highlights the massive philosophical gravity of Novikov's theory. You might build a time machine and travel to the past, but the rigid laws of physics will strictly constrain your free will to ensure historical consistency. You can try to shoot your grandfather, but the gun will jam. You can try to step on a butterfly, but a sudden gust of wind will move your foot. You are entirely a prisoner to a consistent history.
Ultimately, science splits on the solution to all of this. On one side, we have the interacting many worlds theory. Basically, if you travel backward and change something, you spawn an entirely new branching timeline, leaving your original universe perfectly intact. But on the other side, we have fixed space-time, or the block universe. In this view, the past, present, and future are all rigidly written in stone, and we are just experiencing a single slice of it, completely unable to change a single detail.
Which brings us right back to where we started. If we live in a universe governed by Novikov's consistency, we have to ask ourselves a pretty profound question. Considering how our language, grammar, and cognition constantly frame our forward-moving reality, is our deep sense of making choices just an illusion? Is free will merely a byproduct of our biological brains interpreting an already written timeline? Think about that for a second the next time you use the past tense. Thanks for joining me on this explainer. Keep asking the big questions, and I'll catch you next time.